Hello everyone. So previously we solved the problems on this thing, dynamic programming, graphs, as well as the segment and Fenwick tree. So today let's continue with like this thing. I'll be going with some important algorithms that I'll be trying to cover with JavaScript by making use of the JavaScript. Initially, let's start with start with the sorting algorithms. So I'll first let me go with the merge sort. So here we'll be making use of this one, divide and conquer approach, as well as this thing. Let's initially go with the approach, then let's try writing the code, and then let's see and also finally let's discuss the time complexity and the space complexity, right? So that is what we'll be doing here. The first thing is let's understand what merge sort is. So we all know merge sort is nothing but a classic sorting algorithm that employs divide and conquer strategy. So basically, again I'm telling merge sort, I'll just write here MS. Merge sort is nothing but a classic sorting algorithm that employs divide and conquer strategy. So you just have to remember that merge sort employs the divide and conquer strategy. So mainly there are 3 steps that you have to understand in merge sort. I'll be explaining those 3 steps. First thing is divide, conquer, and then combine. So let's discuss the first step. First step is nothing but divide. So here we'll be having the array of elements, right? First. So the array is recursively split into 2 halves. So the array is recursively split into 2 halves here. And also each half contains a single element or is empty. It can be empty, or at least this is minimum criteria. At least it is empty, or it should have the single element. First, the array is recursively split into 2 halves. So let me write here, array is recursively split into 2 halves. So this is the first step. So also the array contains at least the array is empty, or at least it contains the single element. So an array with one element is inherently sorted. So this is, if you are having just one element, it is sorted, right? So they have given the array with one element is inherently sorted. So this is fine. This is the first step. Let's come to the second step. This is nothing but we are dividing. So here in the divide and conquer approach, this is nothing but this is dividing, right? Let's discuss about the conquer. So each half is sorted independently by applying the merge sort recursively. So what we are doing here, each half is sorted independently. Again, we are having 2 halves, right? So suppose this is one half and this is one half. So each half is sorted independently. So this doesn't depend on this one, and this doesn't depend on this one. So each half is sorted independently by applying the merge sort recursively again. So we'll be making use of the recursion, right? So here, second step, nothing but this is divide. This will be conquer, right? So what we are doing here, each half is again I'm telling it is sorted independently by applying the merge sort recursively. Then finally, what we will do, combine. So after this one, we have sorted the each half independently by applying the merge sort recursively. We have to combine them, right? So the sorted halves are merged back together. Here we will merge arrays. So merge 2 arrays, right? So here we will merge back together to form a single sorted array. This will be single sorted array. I'll just give single sorted array, SSA. Let me give. We will be merging two arrays to the will be merging the 2 arrays back together to form a single sorted array. So this merging process is efficient. Why this is efficient? Because arrays are being merged. Arrays that are being merged are already sorted, right? So here this will be sorted and this is also sorted, and then we'll be finally merging. So this is efficient. So let's try to write the code and understand the merge sort, how we how we follow the divide and conquer approach, you'll also understand the divide and conquer approach, as well as finally we'll be going with this thing. What do you call? We'll be discussing about the time complexity and the space complexity, right? Let me delete this one. Initially, what I'll do, let's write the function definition for the merge sort initially. So I'll just consider here function merge sort of parameter array, right? So array of elements we have to take. So I'll just consider ARR for array. So what is the base case? So as we had discussed in the approach, so if the array has only one, or if one element, or if the array is not having any elements in it, nothing but if the array is empty, or it is having the 0 elements, then it is already sorted. Means if we are having only one element in the array, or we are having no elements in the array, then we can say that array is already sorted, right? So I can write in this way: length of the array, nothing but array of the length. Length of the array. If it is less than or equal to 1, then we can just return array. We have considered the parameter ARR, right? So this is fine. Next step is we have to find the middle index to split the array into two halves, right? So we have to first find the middle index to split the array into two halves. So I can write in this way. I'll just take, instead of cons, I'll just take I'll just give middle equals, let me give math.flow of length of the array by, so this will give us the middle index. So let's slice till the left half of the array. Also let's slice till the right half of the array. So that's what we'll be doing. Let's consider the variable left and right, and slice till the left half of the array, and also slice till the right half of the array. So I can simply take in this way: let left equals, so array dot slice will start from 0 index to middle. So we have considered the middle here, this one variable name middle, right? So this will be middle. This is one thing. Also we have to slice the slice till the right half of the array. Slice the right half of the array. I'll just consider right here. This one will be array dot slice of, again, middle. So I hope this is clear. So here the next step is we will recursively sort both halves and merge the sorted halves. So for this we need this one. We have not written the merge function yet. So we will be writing the merge function first. Then we will recursively sort both halves and merge the sorted halves here, right? I'll just leave the space over here. So let's write the merge function first. Then we will come back here. So first let's write the function definition for the merge. I'll just give here function. I'll just consider the name merge. So this will consider the parameters left and right here. Let's consider the parameters left and right. Initially what we will do, we need array. We need to declare the array to store the merged results, right? So we have to store somewhere. The merged results has to be stored somewhere. So we'll be declaring the array to store the merged results. So I'll just give here results equals this one. Let's consider this one, pointers for the left array and the right array. So we'll be going with the two pointers. One is left array, pointer for the left array, and pointer for the right array. I'll just come here. Let me give this one left index, and let me initialize this one to 0. Also I'll just give right index. Let me initialize this one to 0. This is fine, I think. I hope this is clear till here. Next, while there are no elements in both left and right array, suppose we are having two halves now, left array as well as the right array, right? So if we are having no elements in it, then we can write in this way, right? So here, while left index less than length of the left. So here length of the left, and right index less than length of the right. So this one while there are while we have the elements in the left index and the right index, in both left and right arrays, sorry, I said while we don't have elements, right? So while there are elements in the both left and right arrays, then we will compare the elements from both the arrays. So I'll just make use of the if condition here. If left of left index, right of within the array, let me give right index. So then let's add the smaller element to the result. So for adding, I'll just make use of this one. This has to be result. Did I take results? Sorry, I'll just make this one result. So yeah, here for adding the element, I'll just make use of the push. Alright. So it will be, we are adding the smaller element to the result. So it will be left of within the array. Let's mention the left index. So I hope this is clear. Next, after adding the smaller element to the result, we will move the pointer in the left array. So nothing but we will increment the left index, right? So let me increment the left index. So this is it. Next, what we will do. So if there are remaining elements in the left array, if there are elements that are remaining in the left array, then we will add them to the result as well. So here, let's write the while. So left index has to be less than the length of the left, right? So here, I'll just make use of the while loop. It will be left index less than length of the left. So here it will be result dot push. This will be left of left index. So this one will be, finally, let's increment the left index. So this has to be, we will add the left index. Fine. I hope this is clear. Then if there are remaining elements in the right array, means if there are elements that are remaining in the right array, then we will add them to the result as well. First, what we did, if there are elements remaining in the left array, then we added them to the result. Now, if there are elements that are remaining in the right array, then we will add them to the result. So again, I'll copy the same thing over here. Let me make the necessary changes. I'll just paste this one here. Instead of the left index, it will be right index. So also here, it will be less than right. Here also, this will be result of push of, this will be right. I'll just consider a right index. So we are incrementing the right index right here. This one is, I hope this is clear. Finally, we will return the result. Nothing but here we will return the merge sort array. Here, how can we write that? So I'll just come here, return result. So I hope this is clear. I'll just come here. As I have said here before, just give me a second here. So here we have not yet merged the sorted values, right? Sorted halves, right? So at that point of time, I didn't write the merge function yet. So I said here I'll leave the space and we'll write this one later. So let's write this one, this line. This will be, sorry, this has to be, let's return merge of merge sort. Let's merge the left and right. So here I'll come again, merge sort of right, this one. I hope this is clear. So yeah, I think this is clear. Let's check. I'll just, let's see the example usage of the merge sort. I'll just give here const. Let's consider this one example array. So I'll just give here some random elements like 38, let me give 27, 43, 3, 9, 82, some more elements. So yeah, I hope this is fine. That's, I I'll just make use of the console log here. Console log of, let me give, let's consider the original array. So I'll just give here original array, example array. Next, I'll just consider here const. We need the sorted array as output, right? I'll just give sorted array equals merge sort of example array. So we have to get the sorted array in the second step. So I'll just give again console log of here sorted array is, and just consider sorted array. Let me leave the space over here. Sorted array. Also, this will be, this one, sorted array. So let's check here. I'll just come here. Let me click on run. So what's wrong here? Why this is taking time? So somewhere I have done wrong. Let's check what is wrong. So basically we didn't do anything wrong. Here it was not connected to the internet. So let me run this one again. So again, now you can see here we are getting the original array, but we are not getting the sorted array, right? Somewhere we have done a wrong thing in the code. Let's check what is wrong. So what I did here is, let's come here to this step basically. So here we are adding the smaller element to the result, and we are moving the pointer in the left array, right? This one, left index. So here else, same thing we have to do it for the right array as well, right? So I'll just give here a result dot push of, just give a right index. So I hope this is clear. Finally, we will move the pointer in the right array. First, we moved the pointer in the left array here. Now we have to move the pointer in the right array. I'll just give here, let's increment the right index. So I'll just run now. So now you can clearly see we have the numbers 38, 27, 43, 3, 9, 82 and 10 I have given. We are getting the array in this one, ascending order. You can clearly see 3, 9, 10, 27, 38, 43 and 82. So this works absolutely correct. So we have discussed about the merge sort, as well as we discussed about the divide and conquer approach as well, right? So let's finally discuss about this one, the time complexity and the space complexity. Here, the time complexity would be big O of n log n. I mean, why the time complexity is big O of n log n? Because we are repeatedly dividing the array into two halves, as we have discussed. So we are going with the divide and conquer approach, and we are repeatedly dividing the array into two halves, which takes obviously big O of logarithmic n time, nothing but big O of log n, right? And then we will be merging them back together, which takes big O of n time. So the total overall time complexity would be big O of n log n. So I hope this is clear. The time complexity would be big O of n log n here. And what will be the space complexity? So the overall space complexity of this one merge sort will be big O of n. Why? We are just making use of the additional space that is required for the temporary arrays that is used during the merged process, right? So that is the reason the overall space complexity would be big O of n. So this is it. Thanks for watching, guys.